x-axis. By now, it is rotating around y-axis. That is to say, our small change will be in that. That means we are going to have our small change, that is dy, and our that is our height, and that is to say our radius will be x. That is the function evaluated in that form. That is to say, let's have that y equals to 4 minus x squared. We want to have the function in that form. That is, we can make the subject of x, and that is going to be x squared equals to 4 minus y. And then we have x equals to the under root of 4y. Because we have to evaluate that thing there. It will be like that. Now, remember, when we are looking for the intercepts, that was a 0, we know the origin up to that point. That is to say, our volume of revolution now will be found by the formula, we know it, the integral from a to b of the function squared. But our function now is in terms of y. So how will it look like? It will be the volume equals to pi from 0 to 4, and our function now is this one. So it is 4 minus y, 4 minus y, all of that is under root, and that is, now we don't have no more dx, but we have a dy. That will be the change in dy. But remember, that is a square, don't forget that. Now we have to evaluate that. And how will it look like? Let's check it. So up to that point, and then this will be a 4 minus y. If you try to square that, that means the under root and 2 will go. That is, we are left with dy. I know you know how to change the limits, and then we were summing from 0 to 2. Now we are summing from 0 to 4. That means the strips are divided that way. At that time, the strips were divided that way. Now let's see. If you try to integrate that, it's a pi. Inside the bracket, it will be a 4y minus y square over 2 from 0 to 4. And how will it look like again? It will be a pi 4, then times 4 minus y square, that is 4, that is squared, over 2. That is to say, we have pi 16, and then there is 16 divided by 2, it's 8. And if you try to subtract that, it will be 8 pi cubic units. That is the volume when that sketch, or when that graph, or when that function is rotated around the y-axis, and the limits will be from 0 to 4. So that is how we look like. Now let's see the next example. As the example says, using the method of solid of revolution, prove that the volume of a sphere is of the sphere of radius r is 4 over 3 pi r cubic. Now consider the following. Consider you have something like that, and you have a sphere that is in the first quadrant. Let's say this is a part of a sphere, because we know a sphere can be divided into 4 quadrants. But let's have something like that, and then we shall rotate this to form a hemisphere, and then after that we shall multiply that hemisphere by 2, so that we can have the whole sphere. Now let's consider that we have something like that in the first quadrant, and let's say we have that has a radius r, as we have been told, and that radius r, and this point, let's say, is x comma y. That means this is y axis, and that is x axis, and that is the first quadrant. And what do we have again here? We have, if we try to look that much careful, that distance there is x, and that distance there is y. So by Pythagoras theorem, we can say r square equals to what? Equals to x square plus y square. So our r could be what? Let's try to use the function as in y. Square will be equal to what? R square minus x square. So our function could be like this: r square minus x square, and all of that is in under root form. So that will be our function. That will be our function. Now, what is our small change in something like that? Let's have a small change there. That will be a small change in x, and that will be f of x. So we'll evaluate at that point, and then this will be. And what will be our limit? And what will be our limit? Our limit will be, as we know, the distance from that point to that point is equal to x. But this is a radius because it is a circle. Because it is so that means it's a radius. That means our limits will be from 0 to r. Our limits will be from 0 to r. Now let's check it out. We know that the volume of solid of revolution is found by this formula from A to B. F of x, all of that is squared dx. That is to say, pi. And we shall start from 0 to r, and our function is that one. So we have the under root of r square and as x square, and all of that is squared to x. So that is how it will look like. Now let's see. It will be a pi from 0 to r. If you try to do that, it will be r square x square. That is with respect to x. Now let's check it out. Let's try to manipulate that. How will it look like? It will be a pi. That will be r, will be and then minus x raised to 3 over 3. And these limits will be from 0 to r. And now let's plug those. It will be a pi. It will be a pi over what? If you plug it there, it will be r raised to 3 minus r raised to 3 over 3. If you put a 0, then it will be a 0 to the whole expression. Now let's see. It will be a pi. If you try to subtract that, I do hope this multiplied by that point, it will be a 2r cubed. 2r cubed over 3. That is to say, the volume now will be 2 over 3 pi r cubed. Now, this volume we've obtained, as we know that is the volume of the hemisphere. The volume, as we know, it will be the volume of the hemisphere. Now we want the volume of the whole sphere. Now the volume of the whole sphere, that means this must be multiplied by 2. And how do we do that? Let's multiply that by 2. So we have the volume 2. So we have 2 over 3 pi r cubed. That is to say, we have a 4 over 3 pi r cubed. That is the volume, and that is how we show the question like that. We have been told by using the solid of revolution, prove that the volume of the sphere of radius r, and our sphere was that one of radius r, is 4 over 3 pi raised to 3. And we have used these steps, as I was explaining, to show that the volume is equal to that thing. Okay, now let's check the next example. Is example number 3, and find the volume of revolution formed when the area bound by the area. Remember that the area bound by the region x is equal to y square plus 3, and we have x is equal to minus or negative y square plus 5 is rotated through 2 pi. It's rotated through 2 pi radians about y axis. Just remember that. And then remember, it's rotated about 2 pi radians, that is 3/6, and that is the area. That means the area bounded by that. I know you have been doing how to find you have been doing on how to find the volume or the area between two caves. Between two caves. So we are going to rotate that area you've been looking for and see what will happen. And remember, from that point, you have to find the x-intercept. And then after you sketch it, you will see are we talking about and what already we are trying to talk about. I will show you the sketch. Now, this is the sketch. This is the sketch I'm trying to talk about, and I will show you how we are going to end up with such a sketch. And then after that, we shall find the area to that. That means this area is rotated 2 pi. That means it's rotated, let's say, along that in 360 degrees. That means it rotates 360 degrees. And the volume that we are going to look is that thing there. Now let's check it out and let's see how those two functions form that point there. Let's see it. So we have two functions. And our function is x equals to y square plus 3, and we have x equals to negative y square plus 5. Now let's find the limits. And how do we find the limits? And let's find the x-intercept and the y-intercept, and from there we can find the limits and whatever. Now let's see. These two equations are equal. That means we can equate and get the value of y. Let's check it out, and we shall have the following. We shall have y square plus 3 equals to negative y square plus 5. And that is to say, if we collect like terms, we are going to have the following. We are going to have a y square plus y square equals to what? Equals to this goes to that side, equals to 5 minus 3, that is 2y square equals to 2. Dividing that, we are going to have a 1, and then y equals to plus or minus, if you try to find the under root of that. So these are our points of intersections. These are the points of intersections. So if you can find the y-intercept and x-intercept and try to sketch those graphs, these were the points of intersection. Now you can find the x-intercept, and let's say this is f2. That means this is function number 1 and that is function number 2. Let's find the x-intercept function number 1, and if there is y-intercept, and let's check it. How will it look like? Let's check it. So we have for function number 1, that is x equals to negative y square plus 5. What are we going to have? When x equals to 0, it implies that y square equals to 5, and then y equals to plus or minus 5. I think it's just plus or minus under root of 5, sorry. That means it's about 2 point something, because we know that 2 square is equal to 4. That means the under root of 5 is just 2 point something. That means we can sketch somewhere there. And let's have when y equals to 0, that is to say, we are going to put a 0 there, and then we have x equals to 5. That means this is the x-axis. This function number 1 will cut the x-axis at the point where x equals to 5. Now let's check the function number 2. That is x equals to y square plus 3. So when x equals to 0, that is to say y equals to what? Y equals to y square. Okay, when x equals to 0, what are we going to have? We're going to have a y square plus y equals to negative 3. And we know that this will be a complex number. That means y-intercept does not exist. Does not exist. What about x-intercept? Now when y equals to 0, what follows when y equals to 0? When y equals to 0, that means you are going to plug there 0, that is to say x equals to 3. That means we have x-intercept. We have x-intercept. And if you try to sketch that, you will end up having a graph like that. You end up, this was the 2 point I was talking about, somewhere on the first graph, the 2 point on positive side and the negative side, and the x-intercept was 5, and I have obtained a 5 somewhere there. And we have the second graph that was that way. That was we didn't have the value of y-intercept. It was it doesn't exist, so it's not there, as you can see. And we have the value of x-intercept, that is 3. Now we have to find the volume that is formed between these two graphs. That means we have to find the volume of that minus the volume of that, the first graph minus the volume of the second graph. Then we subtract the 2, and then we have the function. Now let's see. But remember, our limits will be in y, that is to say in that form. So we know that the volume of revolution is found by that formula from A to B. But remember, in our example here, we have two functions. That means we have the first function and the second one. And we have seen from the sketch that in order to find the volume of that, we have to take the first minus the second one. And now let's see, we have, that means that is square, the first one, minus when the second one is squared, the second one, they're all squared, and then times dx, that will be the volume. Now let's check it. Let's do it. That means it's pi. Now our limits is from, as we have seen from the sketch, if you try to look that much careful, it will be from -1 to +1. And our graphs are in a very good form. That means we don't need to change anything. That will be negative y square plus 5. This is squared minus we have y square plus 3, and all of that is squared. But all of this will be integrated in respect to y, because our limits are in y, and our small change in y, as you can see there, is from -1 to 1. Let's check it. So be very careful there. So it will be the integral from -1 to 1. There we have a y raised to 4. And then what next? We have this and that, negative y times that is times 2 is 10y square plus 25 minus all of that will be y raised to 4 plus y, and that is a 60. If you take this and that, you multiply y square plus times 3 times 2, that is 6 plus 9. And remember, all of this will be integrated with respect to y. Let's use that part to do that mathematics. So we have a pi, this is volume, remember. So we have, let's collect like terms first, to 1. From -1 to 1 of what? This is -10 square, and that is -6 square. That means collecting those is -16, what? -16y square. And we have a +25 and a -9. Then collecting that is +16 with respect to y. And let's see, is pi, and we can take that 16 out so it can come out there. And then what are we going to be left with? We're going to be left with that thing. So this can be 1 minus y square with respect to y. That is 16 pi. Let's integrate that. It will be y minus y raised to 3 over 3 from negative 1 to 1. And let's try to find that. That means plugging these values there and that negative 1 and subtract. It will be 1 minus 1 over 3. If we try to put small braces there, minus what? Negative 1 minus negative 1, but that is raised to 3 over 3. So be very, very careful, my dear student, on how you can manipulate those parts, because it is on those parts where you miss the answers. Now it is 16 pi. Then if you try to subtract that very careful there, it will be a 2 over 3 minus, let's simplify that. This will be negative and that will be so it will be a negative 1 plus 1 over 3, and that means there will be a negative 2 over 3. And if negative and negative goes, that is to say we are going to have a 16 pi, then 4 over 3. That means our answer will be 64. 16 times 3, this will be cubic units. So this is how we find the volume of the evolution that is found, that is bound by those two functions. Now let's see some few questions here that I'll be leaving for you. I'll be leaving you to calculate or to manipulate. For example, here we have the first one that it says obtain the integration by integration the formula for the right circular cone of radius r and height h, and consider the area enclosed by that is y is equal to h over r x and y is equal to h. So please try to find that and have that formula. And the second example says find the volume of solid of evolution. Actually this second one is very simple. Of solid of evolution generated by rotating the curve y is equal to x square between y is equal to 0 and y is equal to 4 about the x-axis. So the second one is very, very simple. Even the first one is very simple, but it needs you to think a little bit more. The third one says find the volume of solid of evolution generated by the solid of evolution for the region in the first quadrant bounded by the graph of y is equal to the cube root of x, the x-axis, and now here the limits were stated and the function was stated. Y is equal to cube root of x, the x-axis, and the line x is equal to 8. So please remember those, and those are the very basic hints for you to do. And this is rotated about what? First it's rotated about x-axis, and the second time is rotated around in the line x is equal to 8. So these are very few questions, very, very few questions. There are a lot of questions, as I always say, there are a lot of questions, not only this. So please find those questions and do them, and I assure you, you'll have very good performance. Now, my dear students, I will leave you there today. I do hope you have made a lot of revisions as I was explaining this subtopic. So please keep on practicing, as you know you are still students, as I always say. Please, over please, behave, and I assure you, you will succeed in your life. Bye-bye.
Kipindi cha Darasa Online kimeletwa kwenu na Chuo Kikuu cha Sauti Mbeya.
Sanda Records.
Wajukuu zangu, wala msiniogope. Nimekuja, najua mna mengi sana mnataka kunieleza yanayoendelea katika taifa hili tukufu la Tanzania.
Leo tumekumbuka kitambo, miaka mingi ndio imeshapita, umetuachia mifano mpaka leo tunaifuata. Si ulileta muungano na ikaitwa Tanzania, amani yetu na mshikamano mpaka leo twajivunia.
Ukoloni ukopangua, rushwa ukachukia, mwenge tukanyanyua, ukaleta ujamaa na kuvunja ukabila. Asante babu,
yafanya yanaishi babu toka miaka 90 nyuma. Hata wale walokufuata wameifanya nchi imesimama. Na hiyo babu, yeah, naiona kesho yenye mafanikio kwa Watanzania. Naiona kesho yenye maendeleo tunakaribia.
Walimu babu yetu tunakukumbuka, walimu baba yetu tunakushukuru kwa mema uliofanya kwa Watanzania, kwa mema uliofanya